Imagine standing on the surface of another world. The sky glows a soft butterscotch color, and the horizon stretches out in a quiet, endless plain of red dust. The air is impossibly thin, the wind cold and dry, and yet there is a subtle beauty resting over everything. A feeling that this distant place could one day become familiar, perhaps even comforting. This is Mars, the fourth planet from the Sun, a world that has captured human imagination for centuries, and now stands as the leading candidate for humanity's second home. The question of whether humans can live on Mars is not simply a scientific puzzle. It is an exploration of who we are as a species. Throughout our history, humanity has reached for new frontiers, from crossing oceans to reaching the moon. Mars represents the next horizon, the largest leap we've ever considered. Not just a mission, not just a visit, but the possibility of creating a sustainable home on another planet. As we begin this calm and reflective scientific script, imagine yourself drifting slowly through space, approaching the quiet red sphere. Everything is still. Everything is waiting. The future of humanity may unfold here, shaped by challenges, technologies, discoveries, and the instincts that have guided our species through thousands of years of exploration. This script will take you through the many layers of this possibility. The planet's environment, the technology required to survive, the challenges of human biology, the psychological worlds we will carry with us, the ethical questions raised by colonizing a new world, and the profound philosophical shifts that may accompany our expansion beyond Earth. Each section will explore a different angle of this future, unique, vivid, and non-repetitive, building a calm and fascinating journey toward the idea of Mars as our second home. And now, with a gentle breath, let us begin. Section 1. The planet we hope to call home. Before imagining cities beneath translucent domes or the first gardens planted in Martian soil, we must first understand the world itself, the raw, unfiltered, ancient nature of Mars. To build a future there, humanity must become intimately familiar with what Mars offers, what it lacks, and how its environment has shaped the planet into the silent, mysterious world it is today. Mars is often described as Earth-like, but this similarity is delicate, almost poetic rather than practical. In many ways, Mars is a fossil of early planetary evolution, a world that once held rivers, oceans, and a thicker, warmer atmosphere. Scientists believe that billions of years ago, Mars might have been a place where simple life could have existed. Today, however, it is a world frozen in time, cold, thin, silent. But this silence is not empty, it is full of information. A thin breath of atmosphere. One of the most defining features of Mars is its atmosphere, or rather, its lack of one. The Martian atmosphere is only about 0.6% the thickness of Earth's, meaning that even the strongest Martian winds feel like a gentle whisper. This thin layer of gas is made mostly of carbon dioxide, with only tiny traces of nitrogen and oxygen. For humans, it offers no breathable air, no protection from radiation, and very little insulation. And yet, in this delicate atmosphere lies possibility. Because it contains carbon dioxide, it opens the door to plant-based oxygen generation, chemical extraction systems, and even the potential for warming the planet in the distant future. The thinness makes it challenging, but not hopeless. It is a blank canvas waiting for human innovation, a cold but manageable climate. Mars is cold, far colder than any place on Earth. Average temperatures hover around -60 degrees Fahrenheit. At night, temperatures can plummet to -120 degrees Fahrenheit. In the warmest parts of the warmest days near the equator, temperatures might briefly rise above freezing, but never for long. And yet this cold is not unreachable for technology. With proper insulation, energy systems, and pressurized habitats, humans can maintain Earth-like temperatures indoors. The extremity of Martian cold is steady and predictable, unlike the dangerous storms and changing climates of Earth, making it less chaotic and more manageable with engineering. Gravity that changes the human body. Mars has only 38% of Earth's gravity, which raises profound biological questions. How will the human body adapt? Will muscles weaken or strengthen in new ways? Will children born on Mars grow differently? Low gravity might ease movement, reduce injury risk, and make construction easier. But it may also weaken bones and affect cardiovascular systems. Scientists envision exercise machines, rotating sections of habitats that simulate Earth gravity, and new medical approaches that ensure long-term residents remain healthy. Water hidden beneath the surface. Perhaps the most promising feature of Mars is its secretive relationship with water. While the surface appears bone dry, frozen water lies beneath the soil, concentrated in polar caps and hidden underground layers. Extracting this water will be essential, not only for drinking, but for agriculture, oxygen production, and fuel creation. Mars holds enough frozen water to support millions of humans, though accessing it will require machines capable of heating, separating, and purifying it. The knowledge that water is there, waiting, gives Mars the foundation of habitability. Not luxurious, not easy, but possible. Radiation, the invisible threat. Without a magnetic field and thick atmosphere, Mars is bombarded by cosmic and solar radiation. This radiation is invisible, constant, and dangerous over long periods. Living on the surface unprotected would shorten human lifespans dramatically. But Mars offers a natural solution: regolith, the soil itself. Just a few meters of Martian soil can block harmful radiation. Early homes will likely be built underground or covered by thick layers of regolith. In time, advanced materials, magnetic shields, or water-lined habitats may allow safer life on the surface. Radiation is a challenge, but one that can be overcome through thoughtful engineering. A silent world, waiting for discovery. Despite its harsh conditions, Mars is not a hostile world. It is simply quiet, ancient, and untouched. There are no storms like Earth's hurricanes, no tectonic earthquakes, no thriving ecosystems. Mars is a world in stillness. And in this stillness, there is potential for humanity to shape an environment with intention and care. Understanding Mars in its raw form is the first step to imagining life there. Every challenge is matched with a potential solution. Every harsh feature offers a new scientific puzzle. Every empty landscape is a space where human creativity might one day grow. Mars does not welcome life easily, but it also does not push it away. It waits silently for the species bold enough to take its first breath there. Section 2. How we would survive the first day on Mars. Imagine stepping out of the spacecraft after months drifting through the calm darkness of interplanetary space. The landing dust has settled, the engines are silent, and the only sound is the faint wind brushing against your suit. This is the moment the first humans would experience. The first breath not taken from a planetary atmosphere, but from a life support system strapped to their back. The first step onto the red soil, soft and powdery, is a moment carefully rehearsed, yet impossibly surreal. But surviving that first day on Mars is not about heroism. It is about preparation. For all its calm beauty, Mars is a place where every action must be intentional. The environment demands respect, planning, and a deep understanding of what the human body needs to stay alive. This section explores the delicate choreography of survival, how technology, biology, and environmental engineering work together to keep the first settlers safe. A habitat that breathes for you. The moment astronauts arrive, they cannot simply walk into a comfortable home. They must transition from the spacecraft to a pressurized habitat, a structure designed not merely to shelter, but to replace the functions Earth provides automatically. The habitat must breathe in the crew's carbon dioxide and exhale oxygen. It must drink and recycle water, keeping it clean enough to drink again and again. It must maintain humidity, temperature, air pressure, and even the proper mixture of gases. Inside, everything is controlled with precision. A typical Martian habitat would likely consist of several interconnected modules. A life support module, where machines create oxygen, filter contaminants, and condense water vapor from breath and sweat. A sleeping and living module, pressurized to Earth-like conditions for psychological and biological comfort. A laboratory module, where experiments help understand how Mars affects the human body. A greenhouse module, slowly growing the first plants that will make Mars feel less like an outpost and more like a home. The habitat is not just a building, it is a machine, and for the first day, the safety of the crew depends on how smoothly this machine works. The ritual of taking off a helmet. Perhaps the most symbolically powerful moment is when the astronauts enter the habitat and close the airlock behind them. Only after several cycles of pressure equalization, air filtering, and confirmation of safety can they remove their helmets. This simple act, taking off a helmet, becomes extraordinary. The air they breathe is entirely artificial, created by machines. Every molecule of oxygen inside the habitat has been processed, purified, and monitored. The temperature has been chosen, the humidity decided, the pressure calibrated. In a sense, they are breathing designed air. For a moment, the crew might fall silent, aware of how fragile the environment is, and how every breath is made possible by months or years of preparation. It is a moment of humility, one that anchors the reality of life on Mars. The first meal on a new world. Food on the first day is simple. Everything is prepackaged, lightweight, calorie-dense, and scientifically balanced. But eating on Mars is more than nutrition. It is grounding. It is a reminder that even in an alien world, the human routine continues. The crew will gather around a small table, constrained by limited space, and share their first meal. The psychological significance of this cannot be overstated. Eating together reinforces teamwork, reduces stress, and creates a sense of normalcy in a place where nothing is normal. Water for this meal may come from melted ice collected on site, recycled humidity from the astronauts' own breath, or reserves carried from Earth. Every drop is precious. Every sip is a reminder that Mars does not give water easily. Understanding the gravity of 0.38 g. The moment humans step onto Mars, they will feel lighter. Movements will be easier, almost bouncy. Objects that feel heavy on Earth can be lifted with ease. This difference is not only novel, it is a challenge. On the first day, astronauts will test how their bodies respond. How do their muscles react? Is walking stable or awkward? Do tools operate differently? Does balance change unexpectedly? This data will determine how they work, exercise, and even sleep in the coming weeks. Low gravity affects blood circulation, muscle strength, bone density, and even the sensations of space and distance. Understanding these changes early is essential. The first day is not just about adapting. It is about learning to move safely in a body that suddenly weighs much less. The first steps outside the habitat. After resting, adjusting, and verifying that the life support systems are stable, the astronauts will perform their first EVA, an extravehicular activity or walk outside. This is not a triumphant flag-planting moment. It is a calm, cautious, methodical inspection, checking the integrity of solar panels, ensuring the landing craft is stable, examining the habitat exterior, and testing soil consistency for future construction. Walking outside on Mars is slow and intentional. Every step is recorded, every movement analyzed. Even the dust is studied, its electrostatic nature, its grain size, its stickiness. Because Martian dust can cling to suits, clog machinery, and interfere with equipment. Yet, despite these risks, the walk offers a breathtaking gift. The ability to look out over the red horizon and realize this is now home. Communication with Earth, a 5 to 22-minute delay. Nothing on Mars happens instantly. Even communication with Earth is delayed. Depending on the planet's positions, messages take between 5 and 22 minutes to arrive. On the first day, this delay becomes real. If the astronauts feel nervous, Earth cannot immediately reassure them. If they have questions, answers arrive later. If they are excited, they must wait to share their joy. This delay forces a new kind of independence, calm, steady, methodical. It pushes the crew to rely on each other, to make decisions with confidence, and to grow into a new level of self-sufficiency. In time, this communication rhythm becomes comforting, slow, measured, almost meditative. The first Martian night. The first night on Mars is long, nearly 24 hours and 40 minutes. The darkness is deeper than Earth's, with no city lights, no shimmering oceans, no animals stirring in the distance. The only light comes from the habitat's soft glow and the faint shimmer of stars filtered through dust. Inside, the crew sleeps with the gentle hum of machines. Each sound is essential. The pump that filters air, the fan that circulates heat, the soft clicking of water condensers. These are the sounds of survival, the lullaby of the first humans on another world. The first day on Mars is not about achievement. It is about establishing the fragile balance between life and environment. It is a day defined by calmness, care, and quiet awe. Humanity's first sunrise on Mars will come next, not as a victory, but as a beginning. Section 3. Building the first Martian settlements. Life inside a new world. When the first explorers finally step onto Mars, the next challenge arrives quietly in the background. They must build a home. Not merely shelters, not temporary outposts, but the first seeds of a settlement designed to support human life on a planet that has never known it. The air is thin, the soil is harsh, and temperatures swing violently between day and night. Yet within these difficulties lies a strange sense of peace, an invitation to create something new, something that exists nowhere else in the universe. A Martian settlement does not begin as a city. It begins as a rhythm, a steady pattern of survival and adaptation. The habitats, for instance, would be carefully designed to provide safety, comfort, and routine. To an outside observer, they might look like white domes gently pressed into the red ground, or like cylindrical modules connected by soft airlocks and transparent tunnels. The goal is not architectural beauty, but protection from radiation, micrometeorites, and dust storms that drift across the horizon with a whisper rather than a roar. Some scientists imagine inflatables, lightweight structures carried from Earth that expand into large living areas once they arrive. Others propose using the Martian soil itself, compressing it into bricks or melting it into glass-like panels. This concept, known as in situ resource utilization, allows settlers to use Mars as a construction site rather than a distant, remote campsite. There is something calming about this idea, the planet itself becoming a partner in creation rather than a threat to survive. Inside the habitats, life would follow a carefully designed structure. Humans need routine to stay healthy, especially in isolated environments. Morning might begin with artificial sunlight, gradually brightening the living quarters, simulating a warm dawn, even if outside the sky is dim and muted. The air would smell faintly of plants, because hydroponic gardens would grow inside the habitat to provide oxygen, food, and psychological comfort. Greenery becomes more than nourishment. It becomes a reminder of Earth, a thread that ties two worlds together. Water would be recycled with near-perfect efficiency. Every breath, every drop of condensation, every shower mist would be captured, purified, and reused. The settlers would become part of a closed ecological loop, a gentle choreography between technology and biology. It's a peaceful idea. Humanity learning to live with less waste, more balance, more awareness of its environment. The gardens themselves might be the most soothing places in the settlement. Rows of leafy vegetables, small fruiting plants, and perhaps even dwarf trees would grow under soft LED lights. Scientists already experiment with plant species that thrive in low light or tolerate extreme temperature changes. On Mars, these plants would do more than survive. They would comfort. Humans have always found peace in nature, and even in artificial gravity and pressurized rooms, the sight of green life would help anchor emotions, calm stress, and fight isolation. Beyond food and water, settlers would need energy. Fortunately, Mars offers several possibilities. Solar panels, spread out like dark wings across the red sand, would collect sunlight during the day. Despite Mars receiving less sunlight than Earth, solar technology has become efficient enough to compensate. Some settlement plans include small nuclear reactors, compact, quiet, and reliable, offering a steady flow of power through Martian nights. Energy is more than fuel. It is security, warmth, and the heartbeat of the colony. Daily life inside the settlement would be slow and intentional. Without the constant noise of Earth, traffic, crowds, digital overload, the settlers would live with a quiet rarely found today. They might spend mornings maintaining equipment, tending plants, checking the integrity of habitat walls. Afternoons could be dedicated to experiments, studying Martian soil, observing weather patterns, or analyzing ice collected from underground layers. Every piece of data helped shape humanity's understanding of this new world. The evenings might be the most peaceful time. Low-gravity exercise sessions would keep muscles strong, followed by shared meals prepared from the habitat gardens. Afterward, the settlers might gather at a small dome made for observing the Martian sky. Through a thick window, they would see Phobos and Deimos, the small, irregular moons, sweeping silently overhead. Stars would appear sharper than on Earth, steady and unmoving in the thin Martian atmosphere. There is a spiritual calm in imagining these nights, a sense of isolation that feels almost sacred. One of the most surprising parts of Martian settlement is how much of it revolves around psychology. Loneliness, monotony, and distance from Earth can weigh heavily on the mind. That's why architects design communal spaces, not just functional rooms, but warm, friendly, and fun. Inviting environments with soft lighting, spacious layouts, and even soundscapes that mimic Earth. Audio of rain, forests, or ocean waves might play gently in the background, reminding settlers of the planet they came from and the emotional connections they still hold. Communication with Earth would take between 5 and 22 minutes each way. Conversations would feel like echoes, slow and thoughtful. Messages wouldn't be immediate. They would require patience, reflection. Families might send videos instead of live calls. This delay, while challenging, could create a unique sense of calm, a slower pace of connection, where every message carries weight. Outside the habitat, exploration would be deliberate and controlled. Stepping onto the Martian surface requires special suits, pressurized, heavily insulated, and designed to protect against fine dust that clings to everything it touches. Settlers would conduct surveys, build infrastructure, and gradually expand the boundaries of the colony. Every new module, every pipeline laid into the soil, every greenhouse added, would bring Mars one step closer to becoming a true second home. Over time, the settlement would grow. A small outpost might turn into a village, the village into a small town. Children born and raised on Mars might one day walk through these habitats with complete familiarity, feeling at ease in places that once seemed alien to their ancestors. The idea that the human species could one day live comfortably under a red sky is both awe-inspiring and gentle. It reminds us of our capacity to adapt, to create, and to envision peaceful futures, even in distant worlds. A Martian settlement is not a city of noise and speed. It is a quiet choreography of technology and nature, routine and discovery, hardship and wonder. It is a place where humanity learns not only to survive, but to live well on a world that asks for patience, resilience, and imagination. And in those peaceful habitats, under the soft hum of life support systems and the faint glow of artificial dawn, the future of our species might finally feel both fragile and limitless. Section 4. Breathing on Mars. The quest to create a self-sustaining atmosphere. Breathing is something humans rarely think about on Earth. Air surrounds us in an invisible blanket. It has always been there, waiting, effortless and abundant. But on Mars, a simple breath becomes a complex engineering challenge, a puzzle that requires creativity, patience, and an almost meditative understanding of nature. To live on Mars is to learn the art of breathing all over again, but to do so through science rather than instinct. The Martian atmosphere is thin, less than 1% the density of Earth's, and made mostly of carbon dioxide. There is almost no oxygen, barely any pressure, and temperatures that swing too wildly for comfort. This means settlers cannot survive outside without protection, and even inside, breathable air must be produced, maintained, and endlessly recycled. But this challenge is not a limitation. It is an opportunity to explore one of humanity's most elegant achievements, the ability to create a living environment where none exists. The first method of producing oxygen on Mars is mechanical. Machines like MOXIE, the small experimental device sent by NASA, proved it was possible to extract oxygen from carbon dioxide by separating molecules at high temperatures. Scaling this up, early settlers would rely on larger, more efficient oxygen factories. These devices would run quietly day and night, turning the planet's own atmosphere into breathable air. The hum of compressors and the glow of warm reaction chambers might become as familiar to settlers as the sound of wind on Earth. Inside habitats, oxygen levels must be constantly monitored and balanced. Too little is dangerous, but too much also creates risks. Therefore, life support systems would maintain a gentle harmony, removing excess carbon dioxide exhaled by humans, adding controlled amounts of oxygen, and ensuring that humidity and temperature remain comfortable. In such an environment, breathing becomes something intentional, something settlers appreciate more deeply. Every breath is a reminder of the delicate ecosystem they now depend on. Plants, too, become partners in the art of breathing. Inside sealed greenhouses, photosynthesis transforms carbon dioxide into oxygen naturally, just as it does on Earth. These Martian gardens are not only sources of food, but also of air. Quiet, living machines that purify and stabilize the atmosphere, using nothing but light and time. The settlers tend these gardens with care, not just for sustenance, but for survival. There is a calming simplicity in watching leaves unfold, in seeing sunlight touch a plant, and knowing it is quietly creating the oxygen that fills your lungs. Water plays a role as well. Splitting water molecules into hydrogen and oxygen through electrolysis allows settlers to produce additional oxygen whenever needed. But on Mars, water must be treated as something precious. Every molecule counts. Ice found beneath the soil can be melted and purified, but even then, the process requires energy, structure, and careful planning. In Martian settlements, water is not taken for granted. It is managed, recycled, and respected in a way that feels almost spiritual. A more ambitious idea, still theoretical, but deeply inspiring, involves terraforming, changing Mars itself so that one day, perhaps centuries from now, humans might walk its surface without suits. This is not a short-term goal, but a long-term dream, one that asks humanity to think far beyond a single lifetime. The idea is simple in theory. Warm the planet, release trapped gases from the soil and ice caps, create a thicker atmosphere, and eventually spark a cycle that produces more oxygen naturally. But Mars resists this transformation. Its gravity is weak, too weak to easily hold a thick atmosphere. Its magnetic field is nearly gone, allowing solar winds to strip away gases over time. Its soil contains perchlorates that complicate plant growth. Some scientists argue that terraforming may not be possible with current technology, or even within the next few centuries. But others believe that, just as humans once tamed deserts, rivers, and mountains on Earth, they may someday reshape the Martian environment, patiently and carefully. Whether or not large-scale terraforming becomes real, smaller forms of environmental modification are much more achievable. For example, settlers might build enormous enclosed domes, miniature Earths under glass, complete with breathable air, stable weather, and ecosystems adapted for Mars. These domes would serve as pockets of life, islands of Earth-like comfort scattered across the red landscape. Inside them, one might hear the soft whisper of leaves, the trickle of water, or the gentle hum of pollinating insects. Each dome becomes a living world of its own, protected and self-sustaining. Another area of exploration involves engineered organisms. Scientists are already studying bacteria and algae capable of surviving extreme conditions. On Mars, these microorganisms could become the pioneers, the first life to thrive outside human habitats. Specially designed algae might grow in shallow outdoor pools, slowly releasing oxygen while binding harmful chemicals in the soil. Hardy bacteria might help break down perchlorates, making the soil safer for future crops. In this way, life could begin to spread across Mars, not in the wild, uncontrolled way of Earth's ecosystems, but in a careful, guided process designed for stability and balance. Inside the settlements, systems for air recycling are just as vital as production. Humans breathe out carbon dioxide, and without removal, levels could rise quickly to dangerous concentrations. Machines called scrubbers use special materials, often lithium hydroxide or zeolites, to trap carbon dioxide and remove it from the air. These materials are then regenerated, releasing the stored gas outside the habitat. In this looping system, nothing is wasted. Every cycle is another step in the choreography of survival. The emotional experience of breathing on Mars is something unique. On Earth, air is invisible and effortless. On Mars, settlers know every lungful of oxygen has been created intentionally, by machines, by plants, by human ingenuity. This awareness creates a sense of gratitude, a feeling of connection to the systems that sustain life. It makes breathing a daily reminder of resilience and cooperation. Even sound changes in such an atmosphere. The thin Martian air outside carries very little noise, making the world strangely quiet. Inside habitats, the air is warmer and denser, but still not identical to Earth's. Voices might sound slightly different. Footsteps might feel softer. Machines contribute a constant backdrop, the soft whirring of fans, the gentle pulse of air pumps, the distant hum of generators. These become the music of Martian life, steady and comforting. In time, breathing on Mars may come to feel completely natural to those who grow up there. A child born on Mars might one day consider the soft hiss of airlocks and the glow of oxygen monitors as ordinary as birdsong is to a child on Earth. Their lungs will fill with air that did not exist until humans created it, yet for them it will simply be home. In this way, the struggle to breathe on Mars becomes something deeper, a celebration of human adaptability. It shows our willingness to protect life, to build supportive environments, and to carry the breath of Earth across millions of kilometers. In every habitat, greenhouse, and dome, the air becomes a symbol of hope, proof that even in the most hostile places, humanity can create pockets of warmth, harmony, and comfort. Section 5. Martian Agriculture. Growing life on a silent world. Farming on Earth is often a quiet experience. The soft rustle of wind through leaves, the hum of insects, the warming touch of sunlight. But on Mars, agriculture becomes something profoundly symbolic. It means taking a world of lifeless dust and coaxing it, gently and patiently, into supporting life. It is not simply farming, it is the act of awakening a sleeping planet. Martian soil, known as regolith, is not soil in the terrestrial sense. It has no microbes, no decaying organic matter, no familiar scent of earth after rain. Instead, it is a mixture of volcanic rock fragments, iron-rich dust, and sharp mineral grains. Yet within this inhospitable material lies possibility, a foundation waiting to be transformed. The first challenge is removing perchlorates, chemicals that are toxic to humans but common in Martian dust. These must be washed out or broken down with specialized bacteria. Scientists imagine bioreactors filled with hardy microbes working tirelessly to purify tons of regolith, slowly turning it into something plants can safely touch. This process might take days or weeks, but Martian settlers understand the rhythm of patience. On a world where seasons last twice as long as Earth's, time flows differently. Once cleaned, the regolith is enriched with nutrients. Since there are no Earth-like ecosystems on Mars, the concept of compost becomes precious. Every food scrap, every bit of plant material, every fallen leaf from a greenhouse becomes part of a carefully managed cycle. Nothing is wasted. Microbial cultures speed up decomposition, transforming organic waste into dark, nutrient-rich material, reminiscent of Earth's soils. Over time, settlers build an entirely new growing medium, half Martian, half human-made, a blend that marries two worlds. Greenhouses are transparent sanctuaries against the harsh realities of the Martian surface. Outside, temperatures can plunge far below freezing, and cosmic radiation drifts through the atmosphere almost unhindered. But inside, warm light fills the air, filtered through specialized panels that block harmful rays while allowing plants to flourish. These structures might lie low against the ground or be partially buried in regolith for insulation. Inside them, the air feels moist, oxygen-rich, and surprisingly Earth-like. Light must be managed carefully. On Mars, sunlight is weaker, only about half as strong as Earth's. To compensate, artificial grow lights are used, glowing softly day and night, tuned to the exact wavelengths plants crave. These lights are not harsh or mechanical. They emit a calm, steady radiance that gives greenhouses a gentle, dreamlike glow. A passerby outside might see warm golden light spilling onto the red dust, creating the impression that the greenhouse itself is alive. Water is perhaps the most treasured resource in Martian agriculture. It must be recycled endlessly. Vapor from plant transpiration is captured, condensed, and returned to the soil. Wastewater is purified, filtered, and brought back into the system. In this closed-loop environment, every droplet has a purpose. Settlers speak of water with a reverence once reserved for gemstones or rare metals. It is life in liquid form. Hydroponics and aeroponics, so efficient on Earth, become indispensable here. Plants grown in water-based systems require less growing medium and fewer resources, while producing more food. In aeroponic gardens, roots hang in open air, misted periodically with nutrient-rich solution. These systems not only save water, but also grow remarkably fast, allowing settlers to cultivate fresh produce even in limited space. Imagine walking through a Martian greenhouse, long corridors filled with climbing beans, tomatoes suspended like glowing lanterns, spirals of leafy greens stretching toward the light. The air is warm and slightly humid, carrying the faint scent of chlorophyll, a smell tied deeply to comfort and familiarity. On Mars, this aroma becomes a reminder of Earth, a bridge across millions of kilometers. Different plants play different roles. Hardy crops like potatoes, barley, and kale provide calories and nutrients. Fruit-bearing plants, such as strawberries and dwarf citrus varieties, add psychological comfort, offering sweetness and color in an otherwise muted world. Herbs like basil and mint fill the air with soothing fragrances, turning greenhouses into sensory havens. But plants offer more than food. Their presence stabilizes the settlement's atmosphere. They absorb carbon dioxide, release oxygen, and help regulate humidity. In this sense, Martian agriculture is inseparable from life support. Every leaf contributes to the breathability of the habitat, making farming a partnership between plant and human. There is also something meditative about farming on Mars. The world outside is silent, still, and vast. Inside the greenhouse, the only sounds might be the soft trickle of water in hydroponic trays, the quiet hum of circulation fans, or the faint rustle of leaves brushing against each other. Settlers often describe these moments as grounding. While the planet outside is cold and alien, the greenhouse feels warm and alive, a refuge of familiarity, surrounded by an ocean of red dust. Over time, new varieties of crops may evolve or be engineered specifically for Martian conditions. Plants might be modified to thrive in lower gravity, colder temperatures, or higher carbon dioxide levels. Others might be designed to grow faster or produce more oxygen. Martian agriculture could become a kind of biological frontier, an exploration not just of space, but of life itself. One of the most fascinating concepts is the idea of Martian forests. Not outdoors, but inside enormous sealed biodomes. These structures could host trees, dwarf pines, small birches, or fruit trees, creating miniature ecosystems where insects, fungi, and microorganisms coexist. Imagine a dome large enough to walk in, filled with filtered sunlight, the soft crunch of leaves underfoot, and branches swaying gently in the artificial breeze. For settlers, these biodomes would be more than food sources. They would be emotional sanctuaries, places to reconnect with something ancient and instinctual. Children raised on Mars might grow up surrounded by these artificial forests, yet accept them as natural. For them, a tree growing under a dome might seem no stranger than a skyscraper or a subway system seems to a child on Earth. Their sense of home expands to include engineered ecosystems. living spaces that have never existed anywhere except on this one distant world. The psychological impact of Martian agriculture cannot be overstated. Greenery offers comfort. Color breaks monotony. Growth inspires hope. Even a single sprouting plant can lift spirits in ways settlers might not expect. This emotional connection becomes one of the pillars of Martian society. As people farm the red planet, they are also cultivating themselves, nurturing patience, gratitude, and a deep sense of responsibility toward their new environment. Over decades, Martian farms could expand, becoming networks of interconnected green spaces. Settlers may develop culinary styles unique to Mars, built around crops adapted to the planet's rhythms. Festivals might form around harvest times, not out of necessity, but as cultural moments of celebration. In this way, agriculture becomes not just a science, but a foundation for community, identity, and culture. And ultimately, Martian farming is a living reminder of humanity's greatest strength: the ability to bring life into places where none exists. Section 6. The Psychology of the Red Frontier, Living Far from Earth. When imagining a future on Mars, most people think first of rockets, habitats, and technology. But those who would truly inhabit the red planet face something far more profound than equipment. They face the quiet, invisible terrain of the human mind. For on Mars, psychology becomes as essential to survival as air, water, or shelter. The heart and mind must adapt to a world where everything familiar lies tens of millions of kilometers away. Living on Mars begins with silence, a deep, almost ancient quiet that no place on Earth can imitate. There are no birds, no oceans, no rustling forests, no distant cities murmuring beneath heavy air. Outside the habitat, sound barely travels through the thin atmosphere, creating an environment where footsteps seem to dissolve into dust. At first, this silence feels peaceful. Later, it can become a constant reminder of isolation. Settlers must learn to find comfort in stillness, to let it soothe rather than unsettle them. Inside the habitats, life feels intimate and contained. The air is carefully filtered and recycled. The lights follow schedules to mimic the rising and setting of a sun that shines more dimly than the one remembered from Earth. Rooms are compact. Every item has a purpose, and noise from machinery forms a low, steady background hum. For some, this rhythmic mechanical soundtrack becomes reassuring, like the soft breathing of a living settlement. But what truly shapes Martian psychology is not the environment alone, it is the distance. Communication with Earth involves a delay of anywhere between 4 and 24 minutes, depending on the planet's positions. A message sent home does not return instantly. There are no live calls, no spontaneous conversations. Every exchange requires patience. This delay slowly changes the way settlers think, speak, and express emotion. People on Mars learn to pause, to reflect, to measure their words with care. Conversations become thoughtful rather than impulsive. Emotional moments require planning, and misunderstandings take time to resolve. Over the years, these slow communications may reshape the culture that grows on Mars, creating a society that is quieter, more deliberate, and more introspective than the fast-paced world left behind. Another psychological challenge comes from the lack of natural variety. On Earth, even simple things, weather patterns, seasons, the sense of changing landscapes, create a constant feeling of movement and renewal. Mars offers little of this. The sky remains a ruddy beige. The dust lies in familiar patterns, and the landscape changes only with storms or shifting sunlight. This monotony feels serene. To others, it can be unsettling. The mind seeks novelty, and settlers must create it intentionally through art, recreation, or simple rituals. This is why many Mars habitat designs include communal spaces, small lounges with warm lighting, walls gently curved to evoke comfort, and windows that look out onto the stark horizon. Even if the view reveals an endless expanse of rust-colored dunes, the act of gathering there, sharing food, conversation, or silence, strengthens bonds. Human companionship becomes invaluable. People form tighter communities than those on Earth, where space is abundant and distance easy to maintain. On Mars, humanity rediscovers the meaning of interdependence. Every individual contributes something, whether through technical skills, farming, maintenance, art, or emotional support. Trust becomes a cornerstone of survival. A small community of settlers, isolated on an unforgiving world, naturally becomes close, like a family constructed not by birth, but by shared purpose. But community alone is not enough. Settlers also need personal space, moments of solitude that feel safe rather than lonely. Many designs for Martian habitats include quiet pods or small garden corners within greenhouses. Places where a single person can sit with plants, breathe enriched air, and simply be. These spaces serve as psychological sanctuaries, offering peace without isolation. Light plays a critical role, too. With sunlight weaker on Mars and natural day-night cues less familiar, artificial lighting must mimic Earth's rhythms. Warm lights in the morning, cool lights during daytime, soft, golden tones at night. Each helps regulate the human circadian system. Without these cues, sleep would become irregular, mood would fluctuate, and mental clarity would waver. On Mars, even a single illness of the mind can ripple outward, affecting the delicate balance of a small community. Dreams may also change. Some settlers might dream of Earth with vivid detail. Oceans, mountains, rainfall, forests. Waking from such dreams could feel bittersweet. Others may dream of Mars itself, transforming its cold landscapes into symbols of hope or belonging. Psychologists expect that a unique Martian subconscious could arise over generations, shaped by red horizons and distant suns. Homesickness is inevitable. Even the most determined pioneers will feel it. But over time, something unexpected may happen. The longing for Earth blends with a growing attachment to Mars. Settlers begin to recognize beauty in its muted colors, its thin atmosphere, its silent plains. They start to see Mars not as a cold exile, but as a place of possibility, a frontier where humanity writes a new chapter. The mind, adaptable and resilient, learns to love even the unfamiliar. A striking aspect of Martian psychology is the way perception changes in low gravity. Moving requires less effort. Objects fall slower. The body feels lighter. For some, this is exhilarating. For others, it feels alien. But over years, these sensations become normal, embedding themselves into the mind's understanding of home. Children born on Mars may never fully grasp Earth's gravity. To them, leaping higher, lifting heavier objects, and feeling lighter on their feet will be as natural as breathing. Their psychology may differ from Earth-born settlers, shaped not by nostalgia but by curiosity. They may grow into individuals who see Mars not as a frontier, but as a birthplace. The concept of time also subtly shifts. Mars has a longer day, 24 hours and 37 minutes. At first, this might feel strange, but settlers gradually synchronize with it. The extra minutes become part of the rhythm of life. And this reality cultivates discipline, cooperation, and a quiet form of courage. Art becomes essential. Paintings of Earth landscapes, sculptures made from Martian basalt, music echoing softly through habitat halls. Creativity becomes a way to express the human spirit in a place where everything else is utilitarian. Over time, Mars may develop its own distinct artistic identity, shaped by its silence, its light, and its distance. Perhaps the most profound psychological shift comes from the view of the sky. On Mars, the sun appears smaller and cooler. At dusk, the sky turns a gentle blue at the horizon, before fading back to red, a reversal of Earth's colors. At night, stars blaze sharply through the thin atmosphere. Earth appears as a distant, pale blue dot. Settlers may look at that tiny point of light and feel a mixture of longing, pride, and awe. In that moment, a person on Mars realizes something extraordinary. They are part of the first generation of humans to stand on another world and call it home. Section 7. The Psychological Frontier: How Mars Will Change the Human Mind. There are frontiers made of metal, of dust, and of cold Martian soil. And then there are the frontiers that exist entirely within us. As humanity slowly stretches its reach toward Mars, one of the most fascinating and least predictable aspects of this journey is the transformation of the human mind. Not just the physical body adapting to low gravity or thin air, but the emotional, social, and philosophical reshaping that will occur when humans live on a world that is not Earth. In this section, we'll explore the quiet and mysterious psychological dimensions of Mars, how isolation might deepen the human spirit, how the barren landscapes might inspire new forms of creativity, and how seeing Earth from 225 million kilometers away may alter what it means to be human. This is not the story of rockets or habitats. It is the story of consciousness, the weight of distance. When astronauts live on the International Space Station, they can look down and see Earth as a glowing ball of blues and greens. They orbit once every 90 minutes, Communication with mission control is instant, and if something goes terribly wrong, they can be home within hours. Mars is different. A message sent from the red planet could take up to 22 minutes to reach Earth. The return message will take another 22. Emergencies cannot rely on real-time assistance. Conversations with family are slow, delayed, and sometimes emotionally distant. This long delay creates a subtle psychological shift. Humans on Mars will learn to rely on themselves in ways no one on Earth ever truly has. Patience becomes more than a virtue. It becomes survival. And yet, paradoxically, this distance might quiet the mind. With fewer voices, fewer disruptions, fewer real-time interruptions, Martian life may feel strangely peaceful, a place where thought stretches out slowly, uninterrupted. The silence of an entire world. Mars is one of the quietest places in the universe. There are no oceans crashing against rocks, no forests swaying in the wind, no birds, no insects, no distant city hum. The only sounds will be human-made, the low hum of machines, the soft ventilation of air recyclers, and the faint crunch of boots pressing into iron-rich dust. This profound silence may reshape human psychology in ways we've never experienced. Some settlers might feel a deep sense of tranquility, as if the entire planet is meditating with them. Others may find the silence unsettling, too empty, too spacious, too different from the sensory richness of Earth. To ease this, habitations will be filled with Earth-like sounds, the soft splash of digital fountains, simulated birdsong in hydroponic gardens, even artificial breezes created by fans to mimic the feeling of a living planet. But still, Mars will remain a world where silence dominates. And perhaps that silence will teach humanity to listen, truly listen to itself. The psychology of a red horizon. Every sunrise and sunset on Mars is tinted blue. The daytime sky is a pale, dusty orange. The landscapes stretch endlessly, rocky, silent, untouched. For many settlers, this new visual environment may shape emotion and thought in subtle ways. The colors of Mars are not warm greens or ocean blues, but rust reds and pale golds. Psychologists predict that this could lead to heightened introspection. Mars feels ancient, almost sacred. It may force people to look inward. A sense of mythic purpose. The red horizon may give settlers a feeling of being part of humanity's great story. Moments of existential loneliness, sometimes. Looking across a world with no life may amplify the fragility of being human. But these emotional extremes might also forge something beautiful. A new kind of resilience. Humans on Mars may develop a deeper appreciation for life, connection, and the rare miracle of Earth. They may value community more. They may feel a sense of reverence for existence itself. Red planet relationships, friendships, and romances on Mars will form under conditions unlike anywhere else. With small crews, limited space, and close quarters, social dynamics will be intense. People will depend on each other, not only emotionally, but physically. Every task, Every mission, every repair could be life or death. Some psychologists believe this will lead to stronger emotional bonds because trust becomes a necessity, not a choice. New forms of cooperation. Survival requires unity, dissolving many of the divisions present on Earth. A shared identity over time. Settlers may stop identifying primarily as Earthlings and begin thinking of themselves as Martians. This new identity would not be biological, but psychological, a culture born from red skies, fragile habitats, and the knowledge that everyone depends on everyone. The transformation of meaning. Living on Mars may change the human concept of meaning itself. On Earth, life is filled with familiar milestones, careers, homes, travel, birthdays, traditions, celebrations. Mars will rewrite these traditions. Everyday life will become slower, more deliberate, and often more introspective. A walk outside will require a full spacesuit and rigorous planning. A moment of looking out the window will feel like staring into eternity. A simple shared meal will carry the warmth of home in a place that has never known life. Because of this, psychologists predict that humans on Mars will find meaning in small, quiet rituals, shared routines, moments of teamwork, rare views of Earth in the sky, personal growth born from isolation and challenge. Perhaps the greatest change will be philosophical. Instead of taking life for granted, settlers may feel constantly aware of how precious and improbable it truly is. Earth seen from Mars. And finally, imagine the moment a Martian settler looks up and sees Earth, just a tiny, pale blue star, fragile and alone. It will be the single most powerful psychological experience of Mars. From that far away, all conflicts, all divisions, all noise of human life shrink into a single shimmering point of light. Some may cry, some may feel a strange and peaceful calm. Some may finally understand that humanity, despite its flaws, is one family. And perhaps that shift, this deep emotional awakening, is exactly what humans need to evolve. Section 8. Energy and Life. Powering a new world. On Earth, energy feels infinite. Sunlight floods the atmosphere. Wind sweeps across landscapes. Rivers tumble through valleys, and fossil fuels are buried beneath our feet, ready to be tapped. On Mars, energy is scarce, precious, and entirely dependent on human ingenuity. To settle the red planet is to learn not only how to survive physically, but how to harness the forces of nature in ways that are both delicate and profound. The sun shines on Mars, but more weakly than on Earth, about 43% as intense. Yet it remains a vital source of power. Solar panels, stretched across habitats and farms, soak up this diffuse energy, converting sunlight into electricity to run life support systems, heaters, lights, and communication arrays. The panels glint faintly in the dusty landscape, catching the subtle light and turning it into life-sustaining force. To an observer, it may seem almost magical, light from millions of kilometers away, transformed into warmth, motion, and air. Solar energy alone cannot meet all needs. Dust storms, sometimes stretching for months, can cover panels and reduce efficiency. For this reason, settlers may turn to nuclear power. Small, safe reactors designed to provide steady energy regardless of surface conditions. These reactors hum quietly beneath habitats, invisible yet essential. A reminder that energy on Mars is a careful balance between innovation and risk. Their steady glow at night becomes a symbol of permanence in a transient, fragile world. Energy management on Mars is not simply mechanical, it is profoundly psychological. Every watt counts. Every failure has consequences. Lights may flicker during storms. Water pumps may pause if power dips. Even small inefficiencies require attention. Living with such constraints fosters a heightened sense of responsibility, patience, and mindfulness. On Mars, humans learn to treat energy as they once treated air or water, not as a right, but as a gift. Heat itself becomes a form of energy to be managed. Outside, temperatures plunge far below freezing, dipping as low as minus 125 degrees Celsius at the poles during winter. Habitats must be insulated, walls double-layered, floors heated, and life support systems meticulously maintained. Even small failures can endanger life. The warmth inside a habitat, then, is more than comfort. It is a constant reminder of human ingenuity, resilience, and the fragility of survival. Storage is equally important. Batteries must hold excess energy during the day to power the night. They must withstand extreme temperatures, resist degradation, and provide uninterrupted supply for weeks at a time. Settlers develop intimate relationships with these systems, checking them daily, learning their rhythms, understanding their moods. A battery's hum or a slight change in temperature becomes as important as the wind or rain once was on Earth. Wind energy, though less reliable, may still contribute. Mars has storms, gentle breezes, and violent global storms alike. Specially designed wind turbines, compact and sturdy, could convert this motion into usable electricity. Though Mars's atmosphere is thin, even subtle movements of air can be captured and stored, a testament to human determination to harness every possible resource. Beyond survival, energy allows life to flourish. Greenhouses bloom, lights glow warmly, machines churn quietly, and communication systems link Mars to Earth. Energy becomes a medium through which life itself is possible. Every photon captured, every electron stored, every joule transformed, is part of a delicate dance of existence. Without it, Mars remains a cold, barren rock. With it, it becomes a cradle for life, imagination, and culture. Energy infrastructure also shapes the social fabric. Communities organize around power grids, schedules for consumption, and resource sharing. A settlement without excess energy must plan together. Who powers which habitat, when hydroponics run, and how to distribute electricity during storms. This necessity encourages collaboration, communication, and mutual trust. Mars is not just a technical challenge. It is a lesson in cooperation and collective mindfulness. The aesthetic of energy on Mars is subtle but impactful. Solar panels catch the soft, red-tinted light, glimmering like a field of delicate metal leaves. Reactors hum quietly beneath the surface, unseen yet felt.
Lights on habitat walls cast gentle pools of brightness,
illuminating corridors and workspaces in warm, comforting hues.
even a small glow becomes a symbol of life persisting against impossible odds. Energy also holds psychological significance. In the absolute silence of Mars, powered lights, the gentle hum of machines, and the warmth of heated air are reminders that humans are alive, that life persists, and that ingenuity can create stability from emptiness. Settlers may meditate on the subtle sounds and movements of their energy systems, finding reassurance in their reliability. In a world without natural abundance, even electricity becomes a form of poetry. Looking to the future, energy solutions may evolve alongside Mars itself. Massive orbital mirrors could redirect sunlight to farms or habitats, providing more predictable energy than the surface alone. Underground geothermal systems might tap into residual heat from Mars's core, creating a constant and renewable energy source. Even bioenergy may play a role, with genetically engineered microbes converting waste into electricity, forming a closed loop where life sustains energy and energy sustains life. Ultimately, the lesson of energy on Mars is profound. Life depends not only on what exists, but on how it is transformed. Mars teaches patience, precision, and creativity. It demands respect for scarcity, gratitude for abundance, and mindfulness in every choice. On Earth, energy is taken for granted. On Mars, it becomes an intimate companion, a quiet partner in every breath, every movement, every thought. And perhaps in that delicate relationship between humans and energy, Mars reveals something deeper, the way life itself is a constant negotiation with the universe, a delicate balance between scarcity and abundance, fragility and resilience, silence and motion. Every flickering light, every quietly humming reactor, every sun-captured photon becomes a reminder that life can persist even where the universe seems indifferent. That understanding, silent, subtle, and ever-present, is as essential to survival as air, water, or food.
Section 9. Martian Water, Finding, Using, and Preserving Life's Essence. Water is life. On Earth, it flows abundantly in rivers, rains from the sky, pools in lakes, and fills oceans. On Mars, water is scarce, hidden, and precious, a secret that must be discovered, harvested, and preserved with the utmost care. Understanding water on Mars is not just a technical challenge. It is a profound psychological and cultural experience, shaping how settlers live, think, and value existence. The red planet's surface appears dry and lifeless, with vast plains of iron-rich dust, jagged rocks, and craters stretching as far as the eye can see. But beneath this apparent barrenness lies the whisper of water. Frozen ice lurks beneath the surface, often just a few meters down, and pockets of briny water exist in hidden places. Discovering these reservoirs requires a combination of technology, intuition, and patience. Ground-penetrating radar, seismic surveys, and careful sampling become daily tools in a quest that is both scientific and existential. Once located, water must be extracted delicately. Drilling through layers of rock and regolith requires precision to avoid contamination or loss. In some cases, heat may be applied to melt underground ice, allowing it to flow into collection chambers. In other scenarios, chemical processes may be used to separate water molecules from mineral compounds. Every droplet counts. On Mars, water is not a commodity. It is a lifeline. Recycling water becomes an art form. Wastewater, whether from personal hygiene, food preparation, or plant cultivation, is never discarded. Instead, it undergoes rigorous filtration, purification, and sterilization. Humidity from habitats and greenhouses is collected and condensed. Even the tiniest amount of condensation on the walls or pipes is captured and reused. Settlers develop an almost reverent relationship with water, understanding that each drop has traveled far from its original source and will continue to sustain life in countless forms. The scarcity of water influences daily life in subtle ways. Settlers bathe less frequently, but more mindfully, savoring the warmth and sensation of each shower. Every plant in a greenhouse receives water in carefully measured amounts, often delivered by automated systems that mimic gentle rainfall. Culinary preparation adapts to conserve moisture, turning even minimal hydration into a satisfying experience. Water becomes an extension of mindfulness, shaping habits, routines, and awareness. Water also connects life across generations. Children born on Mars may never know the abundance of Earth's rivers and lakes. For them, a flowing stream in a habitat or a small waterfall in a greenhouse is a precious wonder. They learn early to respect it, to marvel at it, and to understand that life depends upon careful management. This culture of water awareness is deeply psychological, cultivating patience, empathy, and long-term thinking in ways that Earth's abundance often fails to inspire. Hydration also affects agriculture. Plants in Martian greenhouses rely on water as much for nutrition as for survival. Hydroponic and aeroponic systems deliver water efficiently, reducing waste while maximizing growth. Mist systems replicate dew, creating microclimates that support delicate crops. Water becomes a medium, not only of survival, but of creation, shaping the contours of life on an alien world. The mental and emotional value of water is profound. In the absolute silence of Mars, a gentle drip of water or the soft hiss of condensation can bring comfort, grounding settlers in the present. Water becomes a symbol of life, continuity, and the human ability to nurture the environment. It reminds settlers that even on a distant, harsh planet, life can flourish if treated with care and reverence. Mars also teaches settlers to respect the invisible dimensions of water. Frozen ice beneath the surface, briny pockets of liquid, or water vapor in the atmosphere are reminders that life's resources often exist in hidden forms. Observing and understanding these subtleties cultivates attentiveness, patience, and a sense of wonder. Every discovery, every harvested droplet, reinforces the connection between human curiosity and the planet's secret abundance. The cultural and social implications of water are equally profound. Settlers may develop rituals around its use, celebrating the extraction of water, honoring its role in cooking or drinking, and observing small festivals to mark rainfall within artificial greenhouses. Water, in this context, becomes a bridge between survival, emotion, and identity. It is both physical necessity and spiritual anchor, a reminder of Earth while simultaneously rooting humans to Mars. Long-term colonization could involve creating vast reservoirs and storage systems. Ice domes might store water in frozen form, slowly melting it to maintain life. Underground tanks could collect and purify water, acting as lifelines during dust storms or seasonal scarcity. Water management will be both technical and artistic, requiring imagination, foresight, and constant care. Scientific exploration of Martian water also opens new possibilities. Life may have existed in these hidden pockets millions of years ago, preserved in ice or briny soils. Microbial life might still survive in isolated locations. Each sample, each analysis, is an opportunity to explore not only the resources needed for survival, but the history of Mars itself. In this sense, water is both lifeblood and story, an element connecting past, present, and future. Finally, the awareness of water scarcity influences the psychology of Martian settlers in profound ways. The knowledge that survival depends upon careful stewardship encourages a mindset of sustainability and mindfulness. Humans become intimately aware of the interconnectedness of life, the fragility of ecosystems, and the responsibilities of creation. On Mars, water is more than H2O. It is memory, morality, and meaning all in one. In every drop collected, purified, and applied, the settlers of Mars reaffirm life itself. In a world stripped of abundance, water teaches gratitude, patience, and resilience. It is a gentle, constant reminder that even on the coldest, driest, most distant planet humans have ever inhabited, life can persist if nurtured with care, respect, and wonder. And perhaps in the quiet reverence for each droplet, the settlers of Mars begin to understand something profound, that life's true value is not in its ease or abundance, but in the tender attention given to each fragile element that sustains it. Section 10. Martian Agriculture. Growing life on a red planet. Life cannot persist without food. On Earth, it comes easily from soil, rain, and sunlight. On Mars, the task of growing sustenance is both a scientific challenge and a deeply human endeavor, a quiet negotiation between technology, patience, and creativity. For Martian settlers, agriculture is more than survival. It is a lifeline, a ritual, and a connection to Earth itself. The Martian surface is not naturally fertile. Its soil, rich in iron oxide, contains toxic perchlorates and lacks the organic matter that plants require. Direct planting in Martian regolith would be fatal to crops. The first step, then, is transformation, creating a medium that can nurture life where none would otherwise thrive. Settlers combine transported earth soils, composted plant material, and sterilized Martian soil to construct a safe growing environment. This act of transformation is symbolic as well as practical. Life must be carefully crafted, not taken for granted. Hydroponics and aeroponics become essential tools. Plants grow not in soil, but in nutrient-rich water or mist, suspended in air and fed precisely controlled minerals. Every droplet is measured, every root observed. Lights are calibrated to mimic Earth's sun, adjusted to deliver the right spectrum for photosynthesis. Timers control light cycles, recreating day and night. Greenhouses hum quietly with the rhythm of life, each system a delicate orchestra that sustains human survival. Martian agriculture demands meticulous attention. Nutrient imbalances, water shortages, or light fluctuations can stunt growth. Small mistakes can have large consequences, so settlers must be both scientists and gardeners, observers of minute changes and patient cultivators. Each harvest becomes a triumph, not just of skill, but of mindfulness, patience, and understanding of the subtle rhythms of life. The psychological benefits of farming on Mars are profound. Tending plants provides settlers with routine, responsibility, and a sense of control in an environment that can feel overwhelming. Watching a seed germinate, a leaf unfurl, or a tomato ripen brings joy and grounding. It is a reminder that even on a world stripped of life, humans can nurture growth, create beauty, and sustain themselves through dedication and care. Greenhouses also become social spaces. Working together to plant, prune, and harvest fosters community bonds. Conversations occur over seedlings and water cycles. Laughter echoes among the racks of growing plants. The simple act of sharing food grown by hand reinforces trust, collaboration, and emotional resilience. On Mars, agriculture is as much about nourishing the mind and heart as it is about nourishing the body. Variety is essential, both for nutrition and morale. Crops must provide not only calories, but also essential vitamins and minerals. Leafy greens, root vegetables, legumes, and grains are carefully balanced to create a diet that supports physical health. Flavor and texture are also considered. Food that delights the senses becomes a source of comfort, a reminder of earthly pleasures, and a vital mental boost in a stark landscape. Experimentation is a constant part of Martian agriculture. Settlers explore new plant species, test growth under different light spectra, and adapt cultivation techniques to local conditions. Mutations may occur naturally or be guided through careful genetic selection to create varieties suited for low gravity, limited sunlight, or scarce water. Each success represents the triumph of human ingenuity, while each failure teaches humility and patience. The psychological impact of nurturing life in a barren world cannot be overstated. Settlers develop a deep bond with their plants, sometimes speaking to them, observing subtle changes in leaves and stems, or crafting miniature rituals around watering and care. This relationship fosters empathy, attentiveness, and a profound sense of purpose. Plants become companions, symbols of persistence, and markers of human presence on an alien planet. Agriculture also teaches long-term thinking. Crops take weeks or months to mature. Planning, scheduling, and anticipation are required. Settlers learn to consider cycles of growth and decay, to adapt to delays and setbacks, and to celebrate small victories. This slow, deliberate approach reshapes perception of time, emphasizing patience and mindfulness in a way few earthbound experiences can replicate. Innovation extends beyond the greenhouse. Soil regeneration techniques, water recycling, and energy-efficient lighting systems are developed in tandem with crop cultivation. Waste from humans and plants is composted and repurposed, creating closed-loop systems that mimic natural cycles. Each innovation becomes both practical and symbolic, a demonstration that life can thrive even in conditions that appear hostile. Food preservation is equally important. Excess produce must be stored safely to endure dust storms or periods of limited light. Techniques such as drying, freezing, or fermenting become essential. Settlers learn to value every leaf, root, and grain, understanding that waste is not an option. These practices instill a philosophy of sustainability that may carry forward through generations, shaping a Martian culture attuned to balance and resourcefulness. Ultimately, agriculture on Mars is a quiet testament to human resilience. It demonstrates that even in a world devoid of life, humans can create, nurture, and sustain existence. It is a daily practice of hope, patience, and care, reminding settlers that life is not only survival, it is cultivation, beauty, and connection. In the soft glow of greenhouse lights, amidst the gentle hum of hydroponic systems, Mars begins to feel less alien. Through the act of growing food, settlers claim a piece of the planet, transform its barrenness into vitality, and learn that life, delicate, persistent, and beautiful, can exist anywhere if tended with intention and love. And in that quiet act, Mars teaches perhaps its most important lesson, that wherever humans go, the capacity to nurture, to create, and to sustain life is as vital as the air we breathe and the water we drink, shaping both the world around us and the hearts within us. Section 11. Martian Architecture. Living in a new world. On Earth, humans take shelter for granted. Buildings provide warmth, protection from storms, and a canvas for expression. On Mars, architecture is not simply about aesthetics. It is about survival, psychology, and creating a home on a world that is alien in every way. The design of Martian habitats will shape not only physical safety, but mental well-being, social cohesion, and the human experience itself. Martian architecture begins with necessity. The thin atmosphere offers no protection from cosmic radiation, and temperatures plummet far below freezing. Habitats must be airtight, thermally insulated, and shielded from radiation. Every wall, floor, and ceiling is a barrier between life and the unforgiving environment outside. Engineers must balance function with comfort, creating spaces that are safe yet livable. Materials are carefully chosen. Metal alloys, reinforced plastics, and 3D printed regolith composites combine to form structures strong enough to withstand dust storms, yet light enough to transport or construct remotely. Domes, cylinders, and modular units dominate early designs, optimized for efficiency and strength. Some visionary projects imagine habitats carved directly into Martian rock, using the planet's natural mass as protection. Each choice represents a dialogue between human need and planetary reality. Inside, architecture nurtures life. Habitats are divided into zones: living quarters, laboratories, communal spaces, greenhouses, and recreation areas. The arrangement of these spaces reflects both practical needs and psychological considerations. Narrow corridors may be avoided in favor of open areas that reduce stress. Natural light is simulated through LED systems, mimicking Earth's diurnal cycles to regulate circadian rhythms. Even color schemes are chosen with intention. Soft tones evoke calm. Greens remind settlers of vegetation, and warm hues create a sense of comfort. Privacy becomes a precious commodity. In small crews, individuals must coexist in close quarters, balancing social interaction with personal space. Modular rooms with soundproofing, retractable partitions, and private pods allow settlers to retreat when needed. The architecture itself becomes a tool for emotional regulation, teaching inhabitants the subtle art of coexistence and self-care in confined environments. Communal spaces are equally important. Shared kitchens, lounges, and workshops foster cooperation and social bonding. Here, conversation flows, meals are shared, and collaborative problem-solving occurs. These areas are designed to support both activity and relaxation, offering settlers a sense of community that counters the isolation of the Martian landscape. Architecture, in this sense, is as much about shaping relationships as it is about shelter. The exterior design of habitats also plays a psychological role. Rounded shapes, smooth surfaces, and organic curves may reduce stress by mimicking natural forms, contrasting with the harsh, jagged Martian terrain. Observation windows offer glimpses of the red horizon, the pale blue earth in the distance, and the occasional dust storm sweeping across plains. Visual connection to the planet outside reinforces awareness and curiosity, reminding settlers of their place in the universe. Flexibility is crucial. Mars is unpredictable. Dust storms, shifting soil, and evolving settlement needs require adaptable structures. Modular components allow habitats to expand, contract, or reconfigure. Walls can be moved, greenhouses connected or separated, and laboratories relocated. This adaptability not only supports survival, but fosters creativity, giving settlers agency in shaping their environment. Energy efficiency influences architectural choices. Insulation, compact design, and integrated systems reduce the demand on power supplies. Habitat orientation considers sunlight for warmth and solar panels for electricity. Ventilation systems circulate air efficiently, while water recovery systems are integrated into walls and floors. In every aspect, the architecture embodies a balance between life, resources, and the planet's constraints. The interiors of habitats become places of imagination,
Settlers might decorate with images of Earth, books, musical instruments, or art, infusing sterile modules with warmth and personality. Personalization is critical for mental health. Each inhabitant's space becomes a sanctuary amidst the alien environment. Architecture is no longer neutral. It is deeply human, a reflection of identity and culture in a foreign world. Noise management is another architectural consideration. Mechanical systems hum constantly, and air circulation generates soft sounds. Designers aim to minimize stress by incorporating acoustic dampening materials, creating quiet areas, and isolating machinery from living spaces. Settlers develop sensitivity to these subtle auditory cues, learning to read the hum of life support systems as a signal of habitat health. Even recreation influences architectural design. Small gyms, climbing walls, or exercise pods provide physical activity, while meditation rooms or observation decks offer mental reprieve. Artificial gravity may be simulated in certain areas to support physical health. Architecture, in this way, is intertwined with the rhythm of life, guiding movement, rest, and reflection. In essence, Martian architecture is more than construction. It is a bridge between survival and humanity. Every curve, every panel, every window is a choice that impacts physical safety, mental resilience, and the quality of life. The habitats themselves become teachers, showing settlers how to live thoughtfully, adapt creatively, and inhabit a world that is both beautiful and perilous. By transforming the barren landscape into spaces of warmth, beauty, and community, architecture allows settlers not only to survive, but to flourish. It demonstrates that human ingenuity can create life-supporting environments anywhere, turning desolation into home, isolation into society, and emptiness into meaning. In the quiet glow of a Martian habitat, settlers may pause by a window, watching the red plains stretching endlessly. They may feel a sense of pride and comfort, knowing that every wall, floor, and light has been designed to sustain life, nurture the mind, and hold humanity's fragile flame against the vastness of space. And perhaps in that silent, carefully constructed space, they come to understand that architecture is not just about shelter. It is about hope, creativity, and the enduring human ability to shape a world into a home.
Section 12. Health and Medicine. Caring for the human body on Mars. On Earth, the human body is supported by abundant oxygen, stable gravity, and ecosystems teeming with life. On Mars, the rules are different. Every breath is filtered, every movement requires adjustment, and every illness carries new significance. Medicine and healthcare on Mars are not simply practical. They are deeply intertwined with psychology, ingenuity, and the delicate art of preserving life in a world far from its natural home. The first challenge is gravity. Mars has only 38% of Earth's gravity, which affects muscles, bones, and even internal organs. Astronauts on long-duration missions in microgravity have already shown the risks: muscle atrophy, bone density loss, and changes in cardiovascular function. On Mars, gravity is slightly stronger than in orbit, but it is still insufficient to maintain Earth-normal physiology without intervention. Exercise becomes not just a choice, but a critical medical necessity. Settlers use resistance bands, exercise bikes, treadmills, and specialized machines to maintain strength. Every hour spent moving is an act of survival, an investment in health, and a mental ritual. Nutrition intertwines with health. The Martian diet is largely grown in greenhouses, supplemented with stored food supplies. Every nutrient is calculated, every meal planned. Vitamins, minerals, and proteins are carefully balanced to support immune function, bone health, and cognitive ability. Eating becomes both sustenance and ritual. Meals are slow, deliberate, and meditative, reinforcing awareness of the body's dependence on carefully managed resources. Medical infrastructure must be self-sufficient. Hospitals, as known on Earth, cannot exist on Mars. Instead, compact clinics are equipped with diagnostic tools, telemedicine links to Earth, and automated systems capable of minor surgeries or emergency interventions. Settlers learn first aid, surgical basics, and the management of chronic conditions. Each person becomes both patient and caretaker, creating a culture of shared responsibility and attentiveness. Illness takes on heightened meaning. A cold or minor infection that would be trivial on Earth can become serious on Mars. Microbes behave differently in controlled environments. Immune systems may adapt unpredictably, and the absence of Earth's biodiversity can reduce exposure to familiar microorganisms. Preventive care, hygiene, and monitoring become central to daily life. Every cough, fever, or rash is treated with vigilance and respect, because the consequences of neglect are far more serious than on the home planet. Psychological health is equally critical. Isolation, confinement, and the monotony of Mars can lead to stress, anxiety, or depression. Mental health care is embedded in habitat design and daily routine. Meditation, counseling, community support, and recreational activities are carefully integrated. Digital tools, virtual reality environments, and Earth-simulated landscapes provide comfort and cognitive stimulation. Mental health is not secondary. It is as essential as oxygen or water. Sleep cycles are another challenge. Mars has a 24.6-hour day, slightly longer than Earth's. Subtle mismatches with circadian rhythms can affect mood, cognitive function, and immune response. Settlers use artificial lighting to simulate Earth-like day and night, carefully timed to regulate hormones and promote healthy sleep. Habitats may include darkened pods, soundproof areas, and soft ambient music to help maintain restful sleep, creating a rhythm of life that supports both mind and body. Medical technology must also adapt to limited resources. Antibiotics, surgical instruments, and medical supplies are finite. Preventive care is emphasized, and improvisation becomes necessary when unexpected conditions arise. A broken bone may require creative splints or supports. Minor surgeries might need robotic assistance. Settlers cultivate problem-solving skills, combining technical knowledge with intuition and adaptability. Every medical decision carries weight, fostering a deep respect for the human body and its fragility. Telemedicine connects Mars to Earth, yet delays of up to 22 minutes in each direction create challenges. Real-time consultation is impossible, requiring Martian crews to make critical decisions independently. This fosters confidence, responsibility, and self-reliance, but also pressure and stress. Settlers learn to trust their training, their instincts, and each other, creating bonds strengthened by shared responsibility for life and health. Emergencies highlight the precariousness of life on Mars. Dust storms, low temperatures, and environmental hazards can quickly escalate minor injuries. Rapid response protocols, emergency shelters, and constant monitoring of environmental conditions are essential. Every member of a crew becomes trained in disaster response, turning survival into a collective, disciplined practice. Long-term medical care raises questions about reproduction, aging, and genetic health. Mars is uncharted territory for human biology, and settlers must navigate these unknowns carefully. Research into fertility, prenatal care, and developmental health is ongoing, emphasizing caution and meticulous observation. Life on Mars is experimental not in risk-taking, but in the delicate pursuit of understanding human biology under entirely new conditions. Technology complements human skill. Artificial intelligence assists in diagnosis. Robots perform precise tasks, and sensors constantly monitor vital signs, atmospheric conditions, and environmental hazards. But despite automation, the human element remains central. Care, empathy, observation, and decision-making are irreplaceable. Medicine on Mars is as much an art as a science, requiring technical mastery and emotional intelligence in equal measure. In this environment, health becomes a shared responsibility and a daily practice. Every exercise, every carefully measured meal, every observation of another crew member's condition contributes to collective survival. Life on Mars teaches settlers that the human body is both fragile and resilient, a masterpiece of biology that must be nurtured, monitored, and honored in ways rarely necessary on Earth. Ultimately, Martian medicine is more than treatment. It is mindfulness. Every breath, every heartbeat, every movement carries significance. The constraints of the environment sharpen awareness, deepen empathy, and cultivate gratitude. Humans on Mars will live with an intimate knowledge of their bodies, their limitations, and their capacities, learning that health is not just absence of disease, but a delicate balance sustained by attention, care, and connection. In the quiet hum of a medical module, with instruments monitoring subtle changes and lights casting a soft glow, settlers come to understand a profound truth. The body is the first frontier, as mysterious and fragile as the planet itself, and caring for it is the foundation of all other endeavors. And in that understanding lies a profound lesson. On Mars, as on Earth, Life thrives not merely through survival, but through attentive care, reverence for the body, and the delicate art of sustaining vitality in harmony with the world around us. Section 13. The Future of Mars. Legacy, Culture, and Humanity's Second Home. As the years turn to decades, the initial settlers on Mars begin to form something far more profound than survival. They are no longer just explorers or scientists. They are architects of a new world, creators of a society, and stewards of a fragile ecosystem. Mars is becoming a home in every sense, a place where humanity can learn, adapt, and flourish in ways that Earth, with its abundance, rarely demands. The culture of Mars will inevitably reflect its environment. Every habit, ritual, and social norm is influenced by scarcity, isolation, and the constant need for cooperation. Celebrations revolve around harvests in greenhouses, milestones in construction projects, or the successful completion of energy systems. Art, music, and storytelling flourish, often inspired by the stark beauty of the red landscape, the silent horizons, and the delicate interplay of light and shadow. Creativity is not just leisure, it is sustenance for the mind, a bridge between the human spirit and a planet that does not nurture it automatically. Education becomes deeply practical. Children born on Mars learn geology, biology, and engineering alongside literature, art, and philosophy. They understand the physics of air, water, and radiation as intimately as they understand grammar and history. Knowledge is integrated into daily life because ignorance is a danger. Survival demands both learning and application. Yet in this necessity, there emerges a kind of freedom. Curiosity is limitless, exploration is constant, and imagination is a tool for shaping the environment itself. Language evolves as well. New terms emerge to describe Martian phenomena: the texture of regolith, the behavior of dust storms, or the nuances of hydroponic growth. Poetry may be inspired by the faint glow of Earth in the night sky, or the silent drift of ice particles across plains. In this way, Mars becomes not just a physical space, but a canvas for human expression, a place where language, science, and art intersect in ways impossible on Earth. Governance and society take unique forms. Decisions must often be made collectively because failure can be fatal. Communities develop systems of consensus, shared responsibility, and mutual accountability. Authority is balanced with cooperation. Each individual's contribution, whether tending crops, maintaining life support systems, or monitoring health, is valued, fostering a profound sense of purpose and interconnectedness. Life on Mars is a daily lesson in collaboration and empathy. Religion, spirituality, and philosophy may also transform. In the vast silence of the Martian plains, humans confront both insignificance and wonder. Observing Earth from millions of kilometers away, settlers develop perspectives on life, time, and existence that are intimate yet cosmic. Reflections on the fragility of life, the vastness of space, and the resilience of the human spirit become part of everyday consciousness, shaping ethics, culture, and personal meaning. Long-term sustainability is central. Every system, water, energy, agriculture, architecture, is designed for resilience and adaptability. Waste is transformed into resources. Closed-loop systems ensure nothing is lost unnecessarily. Martian society becomes deeply attuned to cycles and conservation, a society where scarcity teaches wisdom, patience, and foresight. In this way, humanity learns lessons on Mars that can transform understanding of life on Earth as well. Exploration continues. Beyond the first settlements, humans may venture to the poles, the canyon systems, or even the underground aquifers, seeking new resources, studying geology, and searching for signs of ancient life. Each expedition deepens knowledge, expands territory, and strengthens identity. Curiosity remains a constant companion, as settlers push the boundaries of survival into the realm of discovery. Perhaps most importantly, Mars teaches humans about themselves. Every challenge, every triumph, and every failure is magnified by the starkness of the environment. Settlers learn patience in the slow growth of crops, humility in the face of dust storms, and resilience when life support systems falter. They discover capacities for creativity, empathy, and endurance that earthly comfort rarely requires. In this way, Mars is not just a new home, it is a mirror, reflecting the potential, fragility, and strength of humanity itself. In the soft glow of greenhouse lights, in the hum of life support systems, and in the quiet expanse of Martian plains stretching beyond the horizon, a sense of permanence slowly emerges. This is a world reshaped by human hands and hearts, a place where life has been carved into stone, soil, and sky with care and intention. Humanity is no longer merely surviving on Mars. It is beginning to belong, to leave its mark, and to write the first chapters of a civilization shaped by the lessons of scarcity, cooperation, and wonder. And perhaps the most profound realization of all is this: that Mars, silent and unyielding, has taught humanity the most vital lesson: that life, fragile and precious, can flourish anywhere if nurtured with patience, creativity, and care.